Our next example is of performing division of two rational expressions. So again, linking back to our knowledge that we have of numeric fractions, the way we divide fractions is to multiply by the reciprocal. Or, as some of you come into class knowing it, you keep the first fraction, you change the division to multiplication, you flip the second fraction. So what I'm going to do here is I am going to do any factoring I need to do, as well as creating a multiplication problem. So here goes. My numerator, 8k minus 16, I can factor out an 8. That is the greatest common factor. So 8k, when I factor out an 8, leaves me k. Negative 16, when I factor out an 8, leaves me negative 2. The denominator, this is a monomial. There's no plus or minus, so it's only one term, so it's going to stay 3k. The division turns into multiplication. And now the second fraction, this 4k squared that was in the denominator is now going to move to the numerator and become 4k squared in the numerator. And the 3k minus 6 is going to go to the denominator. And I'm also going to go ahead and factor out a 3. So I factor out the 3, 3k, factor out a 3 leaves me k. Negative 6, factor out the 3 leaves me negative 2. Now, I will do any reducing, and I'll summarize the results. Notice my k minus 2's, those are staring me right in the face, so I will cancel those. I cannot reduce by a factor of 4 because the 8 and the 4 are both in the numerator, nor can I reduce by a factor of 3 because the 3 and the 3 are both in the denominator, but I can cancel a k. The numerator has 2 k's, the denominator has 1, so I can cancel this 1 with one of those. So what do I have left? Well, in the numerator, I have an 8 and a 4k, so 8 times 4 is 32k. And in the denominator, I have a 3 times a 3, or a 9. There is my reduced fraction answer.